The cocktail party effect explained. Part 1. Definition and cognitive mechanism. The cocktail party effect is a phenomenon where an individual can focus auditory attention on a specific stimulus while filtering out a range of other noises, much like tuning into a single conversation at a noisy party. This effect demonstrates selective auditory attention, a critical component of human cognition. It's closely linked to the brain's ability to distinguish signal from noise, using both auditory and cognitive processes to prioritize relevant information. Key to this ability is the brain's capacity to process complex auditory environments. The auditory cortex in the temporal lobe collaborates with higher-order brain regions like the prefrontal cortex to assess and filter incoming sounds. Factors such as voice pitch, intensity, and familiarity play a vital role in making a particular voice stand out against the backdrop of noise. Additionally, the working memory helps sustain attention on the target stimulus, allowing us to follow a conversation even when competing sounds persist. Part 2. Neurological basis and influencing factors. The cocktail party effect relies heavily on the brain's neural networks. The auditory pathway processes sound signals, while the prefrontal cortex applies cognitive control to focus on the target sound. The reticular activating system contributes by maintaining alertness and directing attention to relevant stimuli. The left hemisphere of the brain, often dominant in language processing, aids in interpreting speech, while the right hemisphere handles spatial auditory information, helping to locate the speaker in a noisy environment. Several factors influence the cocktail party effect. Speech familiarity, such as recognizing the voice of a friend or loved one, enhances selective attention. Emotional salience also plays a role. For example, hearing your name across a crowded room will almost always capture your attention. Part 3. Applications and challenges. The cocktail party effect has practical implications in technology, psychology, and medicine. It informs the design of hearing aids and auditory processing devices that help individuals filter background noise in crowded environments. Voice recognition systems, like virtual assistants, are also inspired by this phenomenon, using algorithms to isolate and process specific speech inputs. Psychologists study this effect to better understand attention disorders such as ADHD, where the ability to focus on a single stimulus may be impaired. Additionally, individual differences, such as age and auditory health, impact this effect. Challenges include situations of auditory overload, where the effect breaks down, such as in extremely noisy environments or when the brain is fatigued. Research continues into improving assistive technologies and therapeutic interventions for individuals who struggle with auditory processing. Insights into this phenomenon highlight its importance for effective communication and cognitive function in dynamic environments.